video. Yeah, just take a guess, right? Because before you know the final answer, you should always like trial and error, right? So that's how we deduce the correct answer. You take a claim, guess something, and then you use your action to deduce it. Okay. All right. Let's see. This is 60-degree. And so what happened if you have a 60-degree here, and then these two sides, because these diagonal like this whole total red line, they are all the same, right? So 60-degree, and then these two sides should be the same, right? Right? Do you agree? Yeah. And this is our center, maybe O. Yeah. And then these two should be the same. So then, we deduce more information, more clues. You are guessing like, what happened if I have the top angle 60, and then these two sides are the same. What happened to these two angles? You should have a guess here, right? Yeah, so make a guess. It should be all 60, right? Do you agree? Yeah. You should make a guess and then see if we reach the same answer, right? From your thinking, from your deduction. Do we have the same answer? Okay? Alright. So if this is 60, and then we know here is 60, and now we know that the other half, like here, would be 60 as well, because all these triangles, they are the same, right? Because it's a regular hexagon, and then because we have the size of the hexagons are the same, and then each of these diagonal sides are the same, and yeah, so this would be 60 again, and then so this whole angle, we know it, right? Yeah, so this whole angle, we know it, and so this angle, we will know it, right? This angle will be, what is this angle? It's here, right? So you make a guess and then we compare, right? This angle, yeah, so if you guess it is 120, right? Yeah, and then you know that this is 2, this side, side BC is 2, side BA is 2. Yeah, and then what about AC? The magnitude of the vector, what does the magnitude mean? Magnitude just means the length, right? Because the vector, it has two components. One is magnitude. Magnitude just means the length, all right? So I'm just gonna sorry for scrolling right down here. Yeah, just get used to this language. Whenever is asking you the magnitude of something, and don't get confused, it's just asking you the length, right? So if you have any line, they have a magnitude. Any line segment have a magnitude, how long it is, and they have an arrow means direction, then it just becomes a vector. It's as simple as that. Okay. And now it's asking you like one of the information of the vector, which is the magnitude. Okay, magnitude is just length. Okay, so length AC is something, right? You should be able to write it down yourself, right? Because this whole angle is 60. Then you can definitely draw this picture on your own, and then we compare. Okay. And let me just see. This one is good. Okay. Oh. Okay. Okay. Let me just yeah. Well, you try that question. I will post this. So not wasting any minute. Let's see. This is part 1 of unit 6 recording. Okay, you can keep doing your problem while I'm uploading. Part 1 of unit 6, unit 6.1. Okay, yeah, we're not wasting any time here, because that because I think that triangle length you are able to calculate it yourself, right? Okay, and then this, I'll just upload one of them so you guys can have, okay, this one, so you guys can have a reference PDF, and then we can always yeah. Okay, let's see, where are we right now? So if you finish if you finish, we'll just review. So if we have a triangle 60 degrees and 30 degrees, yeah, let's just compare answers. Okay, this is 2 and it's going to be 1√3. Okay, so this is √3, and then this is going to be the same √3, and this is 2 times √3. So yeah, when you finish, definitely you write something down, and then we compare if it's the same, and then we just keep going. Okay, yeah, but definitely have a paper on your own. Yeah, because it's what I'm doing is just a company for you, right? Company for you, so that we do something together, right? And alright, what about AD? Okay, and then AD is distance, this half, this half. Okay, and as you see, the triangles is like every this little triangle whose every length is the same. Every length is the same, and then we know why is every length the same, because it's 60 degrees, 60 degrees, 60 degrees. Every angle is the same, and we have that formula saying like, okay, maybe we'll have this formula still later. So if, for example, let me write it. If this is CAB, like the side is CAB, and then we have like something like sine 60. So the angle that's across from the side C is 60 degree, right? So 60 sine 60 over c is equal to sine, so b, the angle across from b is also 60 degree, right? Yeah, so sine 60 over b is equal to, and the angle across from a, this side, is still sine 60, right? So sine 60 over a. And then as you see, because the three angles are the same, they're all 60 degree, and then 60 degree, 60, 60, 60, and then because the angle is the same, and then you see the side are the same, right? So A is equal to B equal to C. Well, like I think you probably can't directly tell just from your eyes, because the three angles of this triangle are the same, so the three length sides are the same. Yeah, it's just another way we deduce it from math. Okay, so ABC are the same. That's good. And then one of the side here is 2. So what do we do? Okay, you take a guess. What do we do? It's the same, right? You probably have it in your mind. It's the same. So the other lengths are the same, right? 2, 2, 2 are the same. So that, yeah, then what is AD? So this is 2, and then this is the same triangle is also 2, right? So, yeah, so what is it? You should write it down first. Give you 10 seconds to write it down first, and then we compare our answer, okay? So it is 2 plus 2, right? Right. And then let's see H, equivalent or equal vectors. So two vectors are equivalent or equal if they have the same magnitude and direction. Yeah, sure. Okay. You see, to compare vectors, we're still comparing the two components, the information components of the vectors, right? And one of them is magnitude, and the other is direction, right? Yeah. Yeah, so we have these two components of vectors, right? If these two components are the same, then yeah, the vectors are equivalent. Okay, even if this A, B, C, D a position at different points, but as long as what defines the vector is the magnitude. Magnitude means the length, and the direction are the same. They're parallel, and then they're the same, right? Because we can move vectors around, right? Because vector is not restricted by a starting point, right? We can move the CD vector, move up, and then it just the same shadow as vector AB, right? So vector is really not restricted by any position in your space. It's just characterized by the two. Component information, the magnitude and direction. Okay, so 7. Find the three pairs of equivalent. Find three pairs of equivalent vectors in the next diagram. So let's see. Three pairs of just parallel, and parallel sides has the same length, right? Yeah. So actually, this is not rigorous. It should tell you this is a standard, cubic with the right angles. Yeah, this is boring. Just these are parallel and the same length. Okay. Yeah, so you can get some pairs, say it out loud, and confirm yourself. Okay. For example, EF and AB, and then yeah, FB and GC. Okay, yeah, this is boring. Let's move on. Opposite, just yeah, same magnitude and opposite direction. And as you see, this is quite important. How do you, you know, if two vectors are parallel, how do you write mathematically that they are of the opposite direction? This is actually quite important. Okay, this is actually quite important. I think you will use this in your questions, like comprehensive question in physics. Applies to physics. Okay. You just use this negative sign. Okay, negative sign means opposite direction. Okay, but since you wrote that they're equal, the equal just means like its magnitude that need to be the same. It's just direction is opposite, so that you just add a negative sign, then it's the same. Okay, yeah. So this is important. And okay, find 3 pairs of opposite vectors in previous diagram. Alright, this is again, I think, not so interesting question. Yeah, I'm just gonna, for example, EF. So how to write this vector is actually FE, right? Yeah, because math symbol is like very descriptive, right? So if it is, so starting from F, ending point is E, FE, right? And then AB, yeah, I don't know why are we spending time on this. Yeah, this should be direct. Okay, parallel vectors, two vectors are parallel if their directions are either the same or opposite. Okay, yeah, I think we know this, right? Okay, skip. Following diagram, I identify 3 vectors parallel to parallel to AG. Okay, I think you know. Yeah. If I give this example in exam, you should be very happy, right? Okay, this, and then this, and you can write another opposite vector. Yeah, okay, it's fine. And then okay, direction. Oh, okay, this is something that let's see if I can get this correct. Oh, this is a matter of language. You see the symbol? It looks a bit like strange, isn't it? Yeah, it looks a little bit strange, right? So yeah, so but let's first see this example. What is this example? The second one, okay? The K section, the second like the example here. Yeah, let's just get familiar, comfortable with this. So 5 meters. So 5 meters is usually the length, right? Yeah, I don't even like this symbol. 5 meter. How do I know is okay. And N between N and E is 45 degrees. So 45 degree is angle. It seems like, so from its drawing, it seems like it's the angle of this vector with the n coordinate, right? The n, so n is north, with the north direction. So if you, yeah, so here I think it's application maybe to physics. Instead of xy, and then you partition the space into like 4 directions. So up is always north and south. Yeah, so if you learn geography, and then the west is left, east is on the right. Yeah, so hope you're okay with this. So this coordinate of like north blah 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 is fixed, and then you have this fixed, and then between NE, this angle 45 is always the angle with the angle with respect to direction N, okay, with respect to north. Yeah, but however, this is not clear, not obvious from this notation, right? Because this notation is just rho equal N, rho equal E, and then 45. Yeah, but it seems like from so east, so this read as 45 east of north. So we always like have this north direction as our reference direction, and then we tilt from this north reference, right, and then tilt 45-degree. Okay, whatever this number would be, like 50, and then we just change it like to 50. Yeah, so the reference space is always this north direction. Okay, but this is not clear from this notation, right? Because in this notation it could be confusing. It only give you like N45E, like who knows, right? And then 5 meter is, yeah, 5 meter is length. Okay, okay, 5 meter northeast. And let's see. Okay, so having this example in mind, let's see. K section, express direction of a vector in your horizontal plane. Okay, following the standards, we use a reference system. Reference system is a north, east, west, south. Okay, and the following vectors may be considered also algebraic. And so the true bearing or azimuth bearing, the direction of a vector is given by the angle between the north and the vector. Yeah, that's that example is illustrating, right? So this is important and also quite easy to, very easy to forget, right? So this is the angle between the north and the vector. Okay. Yeah, between the north. Okay. Yeah, so we're always starting from the north, and then see the angle where where the vector is, and then we just draw down. Okay, yeah, so it's not this part. The angle is not, how to say, the angle is not the bottom part. Okay, the angle is always starting from the direction of the north, and then going, oh, where is a vector, and then we stop here, and then this angle that we draw starting from the reference north would be 120 would be our would be our angle. Okay, and then he's saying measuring a clockwise direction. Yeah, so starting from north, clockwise, going down. Yeah, but this clockwise is okay. Just remember, it's between the north direction going with the vector. Okay, and then for example, it's 5 meter per second, 120. Yeah, and here it just give you, it's even more simplified, right? This notation, that's, I guess it's not hard, but that's my purpose of the class. That's almost like why I'm recording this, right? Yeah, because I think this could be a little bit confusing, but apparently under their definition, under this reference system, if you have a bracket, so here is a bracket, right? Like a bracket, and then inside angle, right? And then this angle is whatever between the north versus the r vector, okay? Yeah. Yeah, so this is something, and yeah, this is the reason I want to record this. It's basically just want you guys, like, if you miss the class, want you to remember this. Yeah, and then the length is 5 meter per second. Okay. Yeah, so yeah, hope you have the patience to learn this. Okay, quadrant bearing. All right. Yeah, maybe you have learned this in your geography. Okay. So draw each vector given by magnitude and true bearing. Yeah. True bearing. Okay. Oh, sorry. This is okay. Okay. You see, I even made a mistake. This is a true bearing. Okay. How do I? Their other color. Okay. Let's see. The color yellow. Yellow is good looking. Okay. This is our true bearing. Okay. And then sorry, the second example, but I think this quadrant bearing is even more clear that we went through. This is this is called quadrant bearing. Okay. Yeah, sorry for the, actually these two examples are not even the same. They're different different definitions. Oh wow. Right. Yeah, because this quadrant bearing give you the north and the east. Okay, so that, okay, so quadrant bearing is actually even not bad. They give you the north, and starting from north, of course the angle is not the bottom part. Okay, the angle is not this bottom part. Okay, is this part. Okay. Oh yeah, is this part. Okay. Let me just cross this. So this is not this part. Okay. Yeah. Don't know. And then just a true bearing is our first definition. Okay. So definition 1, right? And then this is definition 2. Yeah. So I wasn't too clear, right, on this, because the first example that we went through is actually definition 2, but which is more clear. Okay, north and east. But this is true bearing. Just maybe have the assumption that the true direction is the north, right? Even if it doesn't have it doesn't have the, yeah, doesn't have the reference north and east, but is only the angle, but it's assuming that, oh, the true direction is north and then the vector. Okay, and so now draw each vector using magnitude and true bearing. Okay, true bearing is just giving you the angle. This is called true bearing. And again, but don't panic about this. Don't panic about these definitions, because we always know that our reference, no matter the true bearing or the what's called quadrant bearing, is always the north is our reference direction. Okay, so the 62-meter. So we first draw the north, and then east, west. Yeah, the rest you can also draw it, and then 60. So starting from the north is our true, bearing direction, reference direction north, and then go down by 60 degrees. You always draw it like this, and then this is 60, right? Yeah, so yeah, the purpose of this recording is just to let you see this. And then 2-meter is our magnitude. Actually, yeah, how is gonna measure your drawing is 2-meter. You simply just draw an arrow as your direction, so that this is your how to say, this is your vector, right? This is your vector, and then direction, magnitude, and then you're fine. Okay, and then B, the same. Always, okay, it's definitely draw on your paper, because you draw one, I think you are okay with this, right? So north, south, west, east, and then this is around like 2. So again, north is a reference, and then going down 25 degree, and then 5 meter per second. Yeah, so it's not bad. All right. Okay. All right. So, okay. 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 So I made a mistake here. The direction is given by the angle between the north-south line and the vector. Yeah. So for quadrant bearing, I made a mistake. So the quadrant bearing, it can actually change. It can actually, north-south line can also, north line can be a reference, and south line can also be a reference. Okay. Okay, so definition, direction given by the angle between the north-south line. Yeah, but here is west, right? Here is a west direction. All right, so okay, this definition is all right, but we're just gonna understand it as, the angle starting from the north-south, this line, starting from the line, and then tilt otherwise. Okay, yeah. So I think this is correct. So south, we're starting from the south, given direction. So first symbol S, okay, and then east. No, north, west. Yeah, we start from the south and then go east. Okay, and then 60 degree. Right, and then B, or of course, 2-meter south, 60 and east, and then B, of course, is it just simply give you the direction west. Okay, yeah, direction west, and 10 Newton west. Okay, course, you can draw this reference. Always draw this reference, as this is our new coordinate system, right? West, east, north, and south. Okay. Yeah. Let me pause this. Okay. We have two small examples. Convert the vector to quadrant bearing. Okay, this first example, let's see, this first example, so the true bearing always have a true direction north, right? North, and then going, the angle is the north, clockwise. The angle with the north direction would be 201. Okay. And the quadrant bearing, so this is our vector here, v, and length magnitude is 5 meters per second. That's all right. And let's see. So this could be this is not northeast, right? Because it's by definition quadrant bearing, the direction given the angle between the north-south line and the vector, okay, and the vector. So this actually can be written as one way. Well, you can try on your own, right? You can definitely try on your own. So this, oh, sorry, 200 and, sorry, I drew it wrong. Did you discover that I made a mistake? 201. So because this is 180 degree, right? So it's 200 already going over here. So this vector is here. Okay. Yeah. So 200 is already going over to here. Okay. And this is, so north, south, east, and west. Yeah. So another way to draw this is that we can, well, okay, you can first try it yourself. I believe you have other ways. So again, we copy this magnitude always the same, and then we can have, because the quadrant bearing is south, north, south as our reference, right? So we can also go south, from the south, and then to the west. Okay, this is one way of doing it. So from the south, because from the definition is saying that north-south line can be a reference baseline. So north-south, this is just going to be 210 minus 180 degree, right? Yeah. So 5 meter per second south, gonna be 30 degree west. Okay. Yeah, and then this to true bearing. Yeah. If you think that this is bored, but we're gonna finish this northwest. Okay, so yeah, again, it's from the north and going 30 degree to the west. Okay, yeah, we just stick to the definition that the quadrant bearing is always the angle between the north-south line with the vector, right? Yeah, read this definition. The direction is always given by the angle between the north-south line and the vector. Yeah. So north-south line is a vertical line and the vector is okay, is of course on the quadrant of north and west. So this quadrant, and the angle between the vector and the north line will be 30. So this will be the vector, this will be the angle between the vector here and north line. Okay, yeah. So for, yeah, so we identify the quadrant will be north and west here. Okay. Yeah, so this is 25 meter north. And then the true bearing, uh, yeah, the true bearing will just be, okay, so true bearing will just be starting from the north and then uh, going clockwise, right? Right, definition. We'll just review, okay, we'll just stick to the definition, it helps us, right? Angle between the north and the vector and measure in a clockwise direction, okay? Yeah, so yeah, so it's like a game. It's like a okay. This is okay. Well, then true bearing we don't say, we don't write down north. Just going from this to here, and it should be 330 minus 30, right? Yeah. So I think it's fine here. Okay. Yeah, you just so I'm also going to share this in the Google Classroom, update this, but you definitely try to calculate it yourself. All right. Um, 6.1 notes. All right, so we pause this.